Hello and welcome to AKS36. AKS36 is graph polynomial functions identify zeros when suitable factorizations are available and showing end behavior. So what I'm going to look for AKS36 is the domain, which is up here, is your domain, range, local max, local min, absolute max, absolute min, increasing, decreasing, your zeros, and end behavior. These are the things you're trying to identify for AKS36. So, this is your equation, minus x to the fourth plus 4x squared. So, when looking for your domain, you want to look at increasing and decreasing. So it starts in the negative, so it's going to be negative infinity to positive infinity. This goes from negative to positive, right? So your domain is negative infinity to positive infinity. Now your range. Your range is from negative infinity to positive 4, since that's your y is positive 4. So, you have negative infinity to positive 4. Okay, you don't have a local max, since it doesn't continue increasing. It goes from increasing to decreasing, so there's no local max. You could put n/a for that. Your local min will be 0, 0, since that's what it hits. So, 0. So as your local min, you see, because this is your minimum, your closest minimum to 0. Absolute max, when you put it in the calculator and identify your absolute max, and when you put it in the graphing calculator to identify your absolute max, you will be left with negative 1.4 right? Oh, negative 1.41 negative 1.41 and 4, and in the second parentheses you want to have 1.41, positive 1.41, and 4. There's both negative and both positive, right? In your absolute min, you don't have one, since it goes on to infinity. You're going forever. So you put n/a for that. You're increasing. When you plug it into your graphing calculator and you look for it, you're going to get negative infinity, so negative 1.41, and then zero, positive 1.41. You see how it comes full circle for your increasing? Like you have 1.41 here, and then your zeros. So that's what comes in. Because when you're looking for your increasing, you're looking for here to here, and here to here. That's why you have two things, since it continues. Alright, so you're decreasing, looking for here to here, and here to here. Alright, and what you're going to get for your decreasing will be negative 1.41, 0, and positive 1.41. Infinity, positive infinity. Then you close off. It's basically this but backwards, if that makes sense, since symmetry on the graph. So that's this but backwards, if that makes sense. But in other cases, it won't always be backwards. Your increasing and decreasing will most likely be different in different graphs. So, and when you're looking for your zeros are when it hits the x-axis, your x-intercepts. So it hits the graph at -2, 0, and +2. So these will be your zeros. -2, 0, and +2 as your x-intercepts or your zeros. And your end behavior will be your x is negative infinity to positive infinity. Hold on. I'll never get good at this. Okay. 2 positive infinity, and then f of x to negative infinity to negative infinity. So this is your domain. Remember, your domain is from where it starts to where it ends. So your domain is negative infinity to positive infinity. Your range is negative infinity to positive 4 because that's where it starts, and its highest point is this highest point. Don't have a local max since it doesn't continue increasing. Its highest point is 4. And your local min is 0, 0 because that's the local lowest. It's not any of these because it continues on and on forever and ever, but that's what's closest to 0. So this is your answer for local min. Absolute max is here. No, absolute max is your highest points. These are your highest points. Don't have an absolute min since you don't have your lowest point, and then your increasing is from bottom to top on both. You can't just do one side. That's why it continues. And your decreasing is from top to bottom. Same thing, can't just do one side since there's both. And that's why it continues. Zeros is where it hits the x-axis. And this is your end behavior for this equation. That's how you do AKS36. I hope this helped. Bye.